Okay, so question 4. We are given the graph of f of x being equals to p to the power of x, and we are told that p must be greater than 0 in the sketch below, and we are given a point which is minus 3 and 27/8. So 4.1, we are asked to show that p is actually equals to 2/3. So remember that we're given f of x being equals to p to the power of x, and to find the value of p you must use the point of a, which is minus 3 and 27/8. So we're going to substitute, knowing very well that this is x value, this is y value. We're going to substitute in this equation here. So where there's f of x, we're going to put 27/8 equals to our p to the power of minus 3. Then to find the value of p, we simply multiply the power to minus 1/3, its inverse. Then we multiply here minus 1/3. So p should be equals to 27/8 to the power of minus 1/3, and you use a calculator, you will find the value to be 2/3. So our p value is definitely 2/3. So 4.2 says that write down the equation of the inverse of f in the form y is equals to. So to write the inverse, we know f of x is equals to p to the power of x, but we calculated p to be equals to 2/3, right? So we're going to substitute that p, so it's going to be 2/3, or let me write it properly. So it's going to be 2/3 all to the power of x, right? So to find the inverse, we say y is equals to into 2/3 to the power of x. Then we swap the x to be y, and y we write x. So meaning where there's y, we put x being equals to 2/3 to the power of y. Then we know very well that we need to write y is equals to. So for us to write y is equals to, we need to solve this problem here using logs, right? So note that this is our base. This is our base, and this is our exponent. So in logs, you should note that log, the base is at the bottom and it's equals to, so this would be the base, this would be the exponent, which is equals to. So our exponent in this case is y, so it's y equals to our log, our base is 2/3, and our value of x, we'll write it here as x. So this would be our equation, which is y equals to log base 2/3 x. So this is our inverse of the function. So 4.3, we are asked to sketch the inverse of the function, indicating all the intercepts and one other point. So what you're going to do, having our inverses, y is equals to log of base, which is 2/3 x, right? So the x intercept, so we need to first find the intercept of the function before we draw it. So the x intercept when y is equals to 0, and our y is equals to 0, log of 2/3 here, and x, so meaning that 2/3 to the power of 0 is equals to x. So therefore our x is equals to 1. So when y is 0, x is 1. So this is the first point of the x intercept. So the y intercept when x is equals to 0, so you have y is equals to log of base 2/3 of 0. So here you won't find a solution. So to draw this function here, so let's say we draw it here at the corner, it's gonna look like this. So you're having our x intercept being 1 and 0, which is somewhere here, 1 and 0. So if we label This is going to be your y-axis. This is going to be your x-axis. So remember that our function does not touch the y-intercept. Hence, we couldn't find the solution of the y-intercept. So it's going to look something like this. It's going to approach the y-intercept, but it won't touch it. And here it's going to move away from the y-intercept. So this would be our inverse of the function. So 4.4, we are told that graph of k is obtained by the reflection of f about the y-axis. Determine the equation of k. Write your answer in positive exponent. Remember that the graph of f of x we found to be 2 over 3 all to the power of x. So if they say k is the reflection of f about the y-axis, so what you're going to do is we're going to say the equation of k is equals to 2 over 3 in place of this exponent of x there, we're just going to write a negative exponent of x, right? Then this means now that our equation of k is going to be the inverse of this. So you're going to write the inverse of this. So instead of writing 2 over 3, you're going to write 3 over 2 all to the power of x. The reason why I did that is I want to make sure that this exponent must be positive as per the question. So this would be our equation of k. 4.5 says that for which values of x will the log of base 3 over 2 of x be less than or equals to 0. What we need to note is since k is equals to 3 over 2 to the power of x, its inverse is log of base 3 over 2 of x. So if you were to draw that inverse, it's going to look something like that. All right. So now we want to identify the values of x such that this log of base 3 over 2 of x is less than or equals to 0. So what are the values of x when this inverse is less than or equals to 0? So these are the solutions of y which are less or equal to 0. We need to note the value of x here. What is the x-intercept at this point? So what you can do is you can find the intercept of this inverse, which is equals to log of base 3 over 2 of x. So if we say x-intercept when y is equals to 0, so if you equate here to be equals to 0, it's going to be 0 is equals to log of base 3 over 2 of x. Then you say 3 over 2 to the power of 0 is equals to x. Therefore x is equals to 1. So meaning that our x-intercept is 1 and 0. So this point here it's 1 and 0. So to go back and answering this question here, saying that what are the values of x when the function is less than or equals to 0? So this is the point where the function is less than or equals to 0. It's this point here. So I'm just going to shade it. So this point here, the function is less than or equals to 0. So to conclude, you can simply say when x is less than or equals to 1, our function is less than or equals to 0. So that is the final solution of x for this problem. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.